All right, everybody, here I am back for the next portion of our calculation. What we're aiming to do here is what we really need to do here is we need to figure out our pKa, because our pKa is arguably the value that's really important for us in order to figure out what our Ka is of our specific acid. Now, the first thing that we did, or what we did yesterday in our calculations, was we played around with a pair of graphs. And the first one was we made our titration curve, which is highlighted here, or which I'm clicking on right now, and I'm clicking on my data. And then what we did was we found our first derivative, and therefore we're able to find our equivalence point. Now, with our equivalence point, we found that basically all of our all of our acid had been neutralized by all of our base at the point where we had added 25.65 milliliters, which I'm highlighting right now, 25.65 milliliters of our strong base, sodium hydroxide. The pH of that was 8.54. Now, what we really need to do is we now need to figure out what is our Ka, but first we're going to find out our pKa. Now, our pKa is also known as our 50% equivalence point, and we're going to be able to find that. And the easiest way that we could do it, or arguably the simplest way we could do it, is we could say, okay, well, we added 100%, or sorry, 100% of our acid was neutralized when we added, well, 100% of base. And that was at 25.65 milliliters of sodium hydroxide. And if we cut that volume in half, well, 25.65 divided by 2 would be around 12.825 or so. And so the easiest thing and the best thing, maybe the best, easiest thing that we could do is say, okay, well, we'll cut that volume in half and let's see what the pH is at that particular volume. Well, we divide that number in two. Do we actually have a pH that corresponds to that specific volume? No, unfortunately, we do not. We have 13 milliliters and we have 9.8 milliliters. Remember, our aim is to find out what is the pH right now, or what is the pH whenever we've added 50% of the required base. We know what it is whenever we've added 100% of the required base, but we want to know what it is when we've added 50% of the base. And we want to be as precise as possible. And so we can't work with the numbers that we have. However, what we can do is we can develop a regression curve and a regression equation. So the way that we're going to do that is the first thing that you're going to need to do is click on your data. Once we look at our data and once we click our chart, what we're going to do with my version of Excel is I'm going to click select data. And whenever I select data, I have a data set that tracks my pH versus my sodium hydroxide concentration. What I'm going to do here is I'm going to add a new data source. And my data source is going to be, I'm just going to call it something simple. I'm going to call it overlay line or regression curve. I'll call it regression. Now, whenever I look at my data, what I want to do is I want to select the data points along, let's see if this works for me, along the basically linear portion of this graph. Unfortunately, my draw tool is not available, but I want basically the flat portion of my line. I want to select all of those data points. Okay, so if I look at this, the first thing that I'm looking at is this point that corresponds to 3.71. And I want to select a linear range within this, on this line, or I want to select data points that give me basically a flat line. So what I'm going to do is I'm going to select this 5, and I'm going to see, well, let's go all the way up to, let's go to this 19. So what I'm going to do for my X values, I'm going to select 5 through 19. Now what that means is I'm going to have to select the corresponding Y values as well. And my Y values, since I'm going from 5 to 19, my Y values are going to range from 3.71 to 4.98. You can go ahead and select OK and select OK. And whenever I get that, I can select this data and I can give myself a solid line. Wait, no, not that. I can now go about selecting these data And if you look on the left-hand side of my screen, I'm only selecting the data set that I want to. I'm going to right-click on this, and I'm going to go Add Trendline. Now, this is going to give me a number of different trend line options. I want a linear line, I want to display my equation, and I want to display my R-squared value, because my R-squared value, that's going to tell me a little bit about the accuracy of my data. Remember, whenever you're looking at it, or sorry, the linearity of my data, the closer your data is to 1, basically the better off your data is, or the more linear it is. I've got a 0.9977. That's pretty darn linear. Now, with this, what I'm going to be able to do is I'm going to be able to look at my Y values and my X values. If we remember, or if we look at this chart, my Y value corresponds to a pH. My X value corresponds to the volume of my titrant, my sodium hydroxide. Now, I've got an equation that is Y equals 0.0873x plus 3.3036. I've written that out just because I like to write things on paper. Not out of habit or hobby or anything like that, but I just have a tendency to do that whenever I'm doing any sort of math problem. So what I'm going to do is, or what I'm aiming to do, is I want to solve for a Y value, because that Y value is going to be my pH. That Y value is therefore going to be my pKa that I want, because when my pH is equal to my pKa, then my I have an equal concentration of my acid and my base. Okay, I've added 50% of the necessary base to titrate 50% of my acid. So what I want to do is I want to plug in that value that I previously looked at. So I took my 25.65, and I divided that by 2. I'm going to use my calculator on my computer. 25.65 divided by 2 equals 12.825. Now that 12.825, given this equation, where am I going to plug it in? Remember, 12.825 is my volume of my sodium hydroxide. I'm going to plug that in to the X value. So now I have an equation that reads Y equals 0.0873 times 12.825 plus 3.3036. So I'm going to say 12.825 times 0.0873 plus 3.3036. That gives me a Y value of 4.4232225. Okay, so that right there is my pKa. This is also my half equivalence point. Now what I want to do is I want to solve for my Ka. Well, my Ka, now with that value that I just solved for, I'm going to rearrange this a little bit and say, what is my Ka? Well, my Ka is going to be equal to 10 to the negative pKa. So 4.4232225. And my Ka resulting from this is 3.77379 times 10 to the negative 5th. There's the Ka for this acid. And that's really all that you needed to do to kind of wrap this up. Well, I hope this was helpful. And if you got any questions, please feel free to send me an email. And if you have any questions about your specific data, let me know. I'll help you out. Thank you very much.